see the drag polar equation. So for every aerodynamics body, we usually will differentiate or they are connected with the values of alpha, quotient of lift, quotient drag in terms of equation or in terms of plot. Let us take this aerofoil or symmetric aerofoil or a symmetric aerofoil. We usually will draw the comparison of aerodynamic values in terms of CL versus alpha. Or for unsymmetric case, we usually should CL and alpha versus alpha in terms of values. So this helps us to understand how the coefficient of lift is varying with respect to attack of various airfoils. Similarly, we also usually use to the coefficient of drag versus the angle of attack. This is also use the different patterns. So here the drag polar means for any aerodynamic body there is a distance between CL and CD that can be expressed in terms of equation or in terms of plot. Both graphical and equation is called as drag. The drag polar. Before that, we need to understand what are the various types of drags is there. So coming to the total drag of any flying aerodynamic body, it is combination of parasite drag, wave drag, and the induced drag. In last class, we discussed about the induced drag and its calculation, the equation, and how it influences with the coefficient of lift and the aspect ratio. And this parasite drag is a combination of spin friction drag, profile drag, form drag, and other the components of aerodynamic bodies over the outer surface due to the air molecules. So this comes under the parasite drag. And wave drag is mainly when the flying object reaches the transonic speed, sonic speed, and supersonic speed. There the normal shock, oblique shock, and then bow shock will produce. That shocks or that waves created the drag to the object. So that drag comes under case of wave drag. And induced drag, we already discussed about induced drag due to the incident angle of the beams are induced due to lift. That is the induced drag. Now we are going to write the equation for all the cases. In terms of this is total drag, that means that this drag is in terms of force. We need to recognize this drag force as the drag function. So this is coefficient of total drag is equal to, let us take coefficient of drag due to parasite, we will take CDE plus coefficient of drag due to wave plus coefficient of drag due to induced drag. So we are considering the three conditions. So balance this coefficient of parasite drag is equal to coefficient of parasite drag due to zero lift, zero pressure condition plus variation of parasite drag. Right? This variation of parasite drag we can write it as first we go with this reason parasite drag calculation or the equation. Next we will go for wave drag and finally we will go for. So now we can replacing. We are rewriting this equation in terms of parasite drag coefficient in terms of lift coefficient. So here CDE zero drag coefficient due to parasite pressure plus this variation drag due to the constant factor K1 into CH1. This is directly proportional to the drag is as well as lift coefficient into twice. So finally we got this CDE and then the parasite drag. Now we move to the wave drag. Wave drag value. Here we need to understand whether it is a transonic speed or supersonic speed or hypersonic speed, and the Mach number will interact here. So here we can write this coefficient of drag due to wave is equal again in zero lift condition. What is the drag coefficient? This is zero wave drag plus variation of drag coefficient due to wave. That is in terms of supersonic speed. Now we can rewrite this equation CdW naught plus here same thing here also it is directly proportional to lift coefficient. So we write the constant factor. This constant factor is involving like this relationship between what Mach number goes. Right? So K to CD, that is CL square. So again we are getting CDW as CD naught plus KCL square. Now coming to induced drag, that is CDI is equal to, we already found this value, that is CL square by aspect ratio into aspect. We are taking this all, let us take this equation 1, equation 2, equation 3 and equation 4. Substituting equation 2, 3, 4 and 1, we are getting CB total drag, the motion is equal to, so 0 Parasite drag plus K1 CL square plus 0 wave drag plus action factor K2 CL square plus induced drag CL square by aspect ratio into Oswald efficiency. So this we can also, this third term, we can also write in terms of 1 by pi, that is we can split this 1 by as K3. So we will get CD E0, that is Parasite drag, plus we will write this coefficient of 0 lift drag due to wave. We can write this K1 plus this K2 plus this entire term will take with as K3. All these are factors, correction factors in various operation conditions. So we can take common term as CL square. So we can write these all things are considered constant, that is will take it as K. So these are in terms of zero lift condition during the Parasite drag, pressure drag, wave drag, form drag, everything. So we can write this equation in terms of CD naught, entire things comes to Parasite wave everything, plus this entire constant will take as K. This is K square. So here we are getting the drag coefficient in terms of final form, that is CD coefficient of drag polar is equal to CD naught plus KCL square. So just now we are arriving on the equation. Now as per the drag polar equation as well as the graph should be as a drag polar. We should draw the graph. Now we are going to be arrived on the equation. Now we are going to draw the graph. So before that, this is here total drag coefficient. CD naught is 0 lift drag due to drag coefficient, and this is lift coefficient. So now we are going to plot the graph between drag polar CD versus CL. So CL versus CD, this is a direction, this is a graph between CD and CD. This region is CD naught region, and this region is KCL square region. So this combined value, this plot is CD naught plus KCL square. This is the graph polar. Okay. So this is graph between CL and CD. Here this is 0, zero drag region, and this graph is drag polar. It's a combination of CD is equal to CD naught plus KCL square. Right? So this both equation and this graph is for drag polar. So we'll see in the next. Thank you.